Good morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about decimal arithmetic unit. So, decimal arithmetic unit, the user of a computer prepares data with decimal numbers and receives results in decimal form. A CPU with an arithmetic logic unit can perform arithmetic microoperations with binary data. To perform arithmetic operations with decimal data, it is necessary to convert the input decimal numbers to binary, to perform all calculations with binary numbers, and to convert the results into decimal. This may be an efficient method in applications requiring a larger number of calculations and a relatively smaller amount of input and output data. So, what is the decimal arithmetic unit? When we are taking the values from 0 to 9, these are called decimal values. These are called decimal numbers. So, computer will understand only binary numbers. But what we have to do, we are converting from decimal to binary and binary to decimal. So, our language is decimal, but system understanding or machine language is a binary number. So, the user of a computer prepares the data with the decimal numbers and receives results in decimal form. So, always the user will take the data from the system, from the machine. It is the decimal numbers. We are sending through the decimal only and we are receiving the decimal form only. But a CPU with an arithmetic logic unit can perform arithmetic microoperations with binary data. But always CPU can understand binary only. CPU can understand binary only. So, we are giving the information from decimal to binary conversion. After the CPU can understand binary. So, CPU can understand binary. So, the user will give the information through the decimal. So, the CPU is understanding binary. So, it is converting from decimal to binary. And outside the CPU, it is the user will understand by decimal only. So, it is converting from binary to decimal. So, user decimal language converting to the CPU is decimal to binary. So, binary language when CPU can understand. What is the output of CPU? It is also binary, but user can understand decimal. So, this binary is converting to the decimal. So, to perform arithmetic operations with decimal data, it is necessary to convert the input decimal numbers to binary, to perform all calculations with binary numbers, and to convert the results into decimal. So, always CPU can do the arithmetic operations, arithmetic logic operations to perform through the decimal numbers only. But ALU can understand the arithmetic logic unit perform binary only. But the arithmetic operations, what is the input of this one is a decimal data, but it is necessary to convert to the binary. So, arithmetic logic unit, what is the work of ALU means it is converting to the decimal to binary. Then operation can be performed. After the operation, it will be transferring to binary to decimal. So, to perform arithmetic operations with decimal data, and it is necessary to convert the input decimal numbers to binary, to perform all calculations with the binary numbers, and to convert the results into decimal. So, this may be an efficient method in applications requiring a large number of calculations and a relatively smaller amount of input and output data. So, it is about the input and output data. Input is the decimal and output is also decimal. In between, what is happening means after the input decimal to binary, before the output binary to decimal will be converting. So, when the application calls for a large amount of input and output data and a relatively smaller number of arithmetic calculations, it becomes convenient to do the internal arithmetic directly with the decimal numbers. Computers capable of performing decimal arithmetic must store the decimal data in binary coded form. The decimal numbers are then applied to a decimal arithmetic unit capable of executing decimal arithmetic microoperations. So what is happening? Always we are converting from decimal to binary, binary to decimal, like this. But why we are doing like this? What is the necessity? Large amount of input and output data is relatively smaller number of arithmetic calculations, and it becomes convenient to do the internal arithmetic directly with the decimal numbers. So always input to output we are going for the decimal numbers. But computer capable of performing decimal arithmetic must store the decimal data in binary coded form. So can understand computer can store binary data. So our decimal values are converting to the binary. Computer can understand, can store the binary data. So in the electronic calculators invariably use an internal decimal arithmetic unit since inputs and outputs are frequent. There does not seem to be a reason for converting the keyboard input numbers to binary and again converting to the display the results into decimal. Since this process requires special circuits and also takes a longer time to execute. Many computers have hardware for arithmetic calculations with both binary and decimal data. Users can specify by programmed instructions whether they want the computer to perform calculations with binary or decimal data. So actually binary to decimal, decimal to binary, where we are happening in the electronic calculators, invariably internal decimal arithmetic unit is there. Calculators are always internally decimal will accept and converting to the binary, and again binary is converting to the decimal. So this does not seem to be a reason for converting the keyboard input numbers to binary and again converting the displayed results to decimals. So before going to the process, the keyboard input numbers into the binary. So keyboard, when we are entering the keyboard, those inputs are binary to converting to the decimal to converting to the binary, and the process required special circuits that takes longer time to execute. What are the special circuits are there? They are converting from decimal to binary and binary to decimal. But many computers have hardware for arithmetic calculations with both binary and decimal data. Users can specify by programmed instructions whether they want the computer to perform calculations with binary to decimal. After always users use computers to perform binary to decimal or decimal to binary. So, a decimal arithmetic unit is a digital function that performs decimal operations. It can add or subtract decimal numbers, usually by forming nines and tens complements of the subtrahend. The unit accepts coded decimal numbers and generates results in the same adapted binary code. A single stage decimal arithmetic unit consisting of 9 binary input variables and 5 binary output variables, since a minimum of 4 bits is required to represent each coded decimal digit. Each stage must have 4 inputs for the odd digit, 4 inputs for the added digit, and an input carry. The output includes 4 terminals for the sum digit and 1 for the output carry. There is wide variety of possible circuit configurations depending on the code used to represent the decimal digits. Okay, so decimal arithmetic unit in the digital function or subtracting, always we are using nines and tens complement or ones and twos complement for subtrahend. In the decimal arithmetic, for the subtraction, we need ones and twos complement or nines and tens complement for subtraction in the decimal arithmetic. And the decimal numbers generates results in the adapted binary code, a single stage decimal arithmetic unit consisting of 9 5 binary output variables, 9 plus 5, 14. And since a minimum number of 4 bits are required to represent each coded decimal digit, each stage must have 4 inputs and 4 inputs for the added digit and an input carry. The output include 4 terminals for the sum digit and one is for output carry. So next we will discuss example how it is happening like this. And there is a wide variety of possible circuit configurations dependent on the code used to represent the decimal digits. Decimal arithmetic unit is a digital function that performs decimal microoperations. So decimal arithmetic unit is using for decimal microoperations. In mainly performs addition and subtraction. So decimal unit is for performance of decimal microoperations. Performance of decimal microoperations. So these are addition and subtraction mainly using for in decimal arithmetic unit. And the addition operation is performed with BCD adder, whereas subtraction is performed with BCD subtractor. Here BCD stands for binary coded decimal, and BCD here is that. So when we are going for the addition and subtraction, we need BCD coded. BCD means binary coded decimal. Binary coded decimal. So BCD adder, whereas subtraction for BCD subtractor. For addition, BCD adder. For subtraction, BCD subtractor. So binary coded decimal, binary coded decimal. It is for, suppose I am taking what are the decimal numbers 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many are there? Total 10 are there. So each decimal, binary coded decimal means I am taking each one as a 0, 0, 0, 0, 0, 0, 0, 1 like this. So up to how we are taking is up to how much? 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 10, 0, 1, 1, 1, like this. Okay. So BCD is a 0 to 9 representing by a 4-bit binary. A 4-bit binary or not? Yes, it is a 4-bit. 1, 2, 3, 4. So 1 bit, 2, 3, 4 bit. So it is a 4-bit binary number. So BCD is the 4-bit binary number. And for example, 374 is a decimal number. Yes, 374. So 3 and 7 and 4 are the beyond the binary numbers. 0 to 9 only. This limit is 0 to 9. So this is a decimal number, whereas 3 and 7, 4 are the decimal digits. So shall we call these a decimal? Yes, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the decimal numbers. So 374 also beyond the decimal numbers only, values only. And by using BCD, we can represent the decimal digit by binary coded. This 374 value we have to convert to the binary. 374 base 10. Why I am calling 10? It is a decimal. Yes, it is a decimal. So 374 base decimal. That means the value is in the form of decimal. Otherwise, I am writing like this. 374 radix 10. That means base 10. So it is a weighting of 8421 code. So how we are calling it is a 8421 code. Means here we can observe here it is the 2 power 0 position, 2 power 1 position, 2 square position, and 2 cube position. So here 2 cube equal to 8, 2 square equal to 4, 2 power 1 equal to 2, 2 power 0 equal to 1. It is called 8421 position. 8421 position. And going from left to right, it is the LSB, and right mode is called the MSB. Most significant bit and least significant bit, 0 0 0 0. So last 0 is a 2 power 0 and 2 power 1, 2 square, 2 cube. 2 cube equal to 8. So why I am taking 2 power 0, 2 power 1 means these are the binary values or not? As they are the binary values, I am representing in the form of binary only. 2 power 0, 2 power 1, 2 square, 2 cube. So 2 power 0 means 1, 2 power 1 means 2, 2 square means 4, 2 cube equal to 8, 8421 position. So I am taking as a 8421 code or 8421 position. Here I am taking decimal numbers are from 0 to 9, 8, 4, 2, 1 position. That means here 0 means 0, 0, 0, 0. 2 power 0, 2 power 1, 2 square, 2 cube, 8, 4, 2, 1 position. So 8, 4, 2, 1 position. For 0, 0, 0 is 0, 0, 0, 0. 1 means 0, 0, 0, 1. How we got the values 1 means here 0, 0, 0, 1. Okay. It is of 2 power 0 position, 2 power 1, 2 square and 2 cube. So you can see here 2 cube into 0 plus 2 square into 0 plus 2 power 1 means 2 into 0 plus 2 power 0 into 1. So it is 0 plus 0 plus 0. 2 power 0 equal to 1. 1 into 1, 1. So 0 plus 0 plus 0 plus 1 equal to 1. So the value is 1. Okay, here I am taking 9. 1 double 0 1. 1 double 0 1. 2 power 0, 2 power 1, 2 square, 2 cube. 2 cube equal to 8 plus 2 power 0 equal to 4. 4 into 0, 0. 2 power 1 is equal to 2. 2 into 0, 0. 2 power 0 equal to 1. 1 into 1, 1. How much now? 9. So I got 9. Yes, I got 9. The above codes are valid for BCD codes. And we look at the invalid BCD codes since we are using 4 bits to represent the decimal digit. And 2 power 4 equal to 16. And 0 to 9. Decimal values are 0 to 9. And 2 power 4 equal to 16 possibilities are there. So how many are there? Means there are 16 possibilities. And 10 to 15 are the considered invalid. Why? Because these are the beyond the 10. Already we got numbering is from 0 to 9 means decimal means 10. Decimal means 10. After 9, the values are invalid. Why? Because I have to take 9 values only. Decimal means 0 to 9. So after 9, we are not validating anything. So here 0, 0, 110. After them 0, 111. 1 triple 0, 1 double 0, 1. So like this, it is a decimal to binary, that is a BCD. So now we are converting the decimal number into BCD. We need to break out the decimal number. For example, I am taking 10 in BCD and 1 and 0 will be the concatenant. So 10 base 10. So the value is 10 base 10 I am taking. I have to convert to the BCD. So BCD means how many digits are possible? 4 digits I have to take. So what is the value of 1? 000 1. What is the value of 0? All zeros. So it is a 0001 and all zeros. It is the BCD conversion. So 10 base 10 is converted to BCD. 10 base 10 is converted to the BCD. And now we must wondering the BCD and binary same? No. Why? Because binary is a 0 and 1 form, but BCD is a binary coded decimal. That is from 0 to 9 we have to take. And let's convert the decimal number 15 into the binary and as BCD. So here I am taking 15 base 10 convert to BCD and binary. Is it possible? Yes, we have to possible to convert to the BCD and binary also. So 15 means what is the one value and what is the 5 value? Here already in the table we have the 5 values there. What is the 5 value here? 0 1 0 1. 0 1 0 1. So what is the total? 0 0 0 1 0 1 0 1. Is it BCD? Yes, it is a BCD. Okay, 15 base 10 is converted to the BCD. But what is the formula for binary? Means how we are converting means to the binary. I am converting to the 15 base 10 to binary. I am taking divided with 2. 2 7 ja 14. 1 is a remainder. 2 3 ja 1. 2 2 ja 1. 2 1 ja 0. 2 zeros ja 1. So what is the value? Bottom to top. 0 1 0 1 0 1 0 1 completed. Double 1. Is it binary? Yes. 15 base 10 I converted to the binary. So 0 1 0 1 double 1 I am converted to the binary. Okay. So BCD addition in replica of the binary. So I am going for the BCD addition. It is what is the condition for BCD means? It is 3 cases. Sum is less than or equal to 9. Finally carry equal to 0. It is the result is correct. Sum is less than or equal to 9 and finally carry equal to 1. Then the result is incorrect. To correct the answer, we just need to add 6 or 0 1 1 0 to obtain the result. Okay. The what is the first condition? Sum is less than or equal to 9 and carry equal to 0 means it is a correct. But sum is less than or equal to 9 and we are getting the carry. It is not a correct answer. So we have to go to the correct answer means we have to add 6 to that number. And sum is greater than or equal to 9. Finally carry equal to 0. It is also incorrect. To correct about this one, what we have to do? Add 6 to this one. So we have to see one base 2 base 2 plus 6 2. Is it addition? Yes. But here it is a decimal number. Why? Because 2 and 6 are the decimal numbers, not a binary numbers. It is a BCD. So what we have to do? 2 double 0 1 0. And what is the 6 value? 0 double 1 0. So 1 0 plus 0 0 1 plus 1 0 0 plus 1 plus 1 0 and 0 plus 0 1. So what is 1 triple 0 value? 8. 8 is less than or equal to 9. S. So it is a beyond the, it is under a limit. And the carry is there? No. So it is correct? Yes, it is correct. I am going for the next 3 base 10 plus 7 base 10 BCD addition. So 3 means 0 0 1 1. 7 means 0 triple 1. So what is means 1 0 1 0. So what is our condition here? Sum is less than or equal to 9, but here sum is greater than 9, 10 greater than 9, and carry is there, there is no carry, but it is incorrect. If we have to change to the correct process, what we have to do? We can add 6 to this one. So I am adding 6 to this one, then I will get the correct answer from this one. How we are adding to this one means we will discuss. The above 6 we can add to the resultant. The question will be arise, why 6? So we are adding 6, that is correct, but why I am adding 6 here? What is the process? Means 4-bit number represents the decimal digit from 0 to 9, but here here what is the process means? It is a 4-bit means it is a 16 digits will become 16 bit. Why? Because 2 power 4 equal to 16. So 4 digits means 2 power 0, 2 power 1, 2 square, 2 cube. So what is a 2 cube? 8 plus 2 square equal to 4 plus 2 power 1 means 2, 2 power 0, 1. 8 plus 4, 12, 14, 15. So total it is a 16 bit. We have to get 16. So already I got only 0 to 9, but I need a 15. How many I need? 15 minus 9, I need 6. So that is the reason I am adding 6 to this one. So what is the previous result here? 1 0 1 0. For this 1 0 1 0, I am adding 6 value. 6 means 0 1 1 0. I am adding all things. Next, what is the result? 0 0 0 0 1. So here 10 base 10 equal to only 1 is there. So I have to add 0001 and all zeros. It is a BCD. Okay. So here we discussed. So 2 means 0010 and 3 means 0011. So it is a BCD value. So how we are getting the values means already we discussed 0 0 0 0, 1 means 0 0 0 1, 2 means 0 0 1 0, so on. 9 means 1 0 0 1. So how we are getting like this means 2 power 0, 2 power 1, 2 square, 2 cube, 8 plus 4 plus 2 plus 1. But here all zeros are there. 8 into 0, 4 into 0, 2 into 0. Here only 1 into 1. 0 plus 0 plus 0 plus 1 equal to 1. So shall we got 1 here? Yes, 1. I am taking here 0 0 1 0. 2 power 0, 2 power 1, 2 square, 2 cube. 2 cube into 0, 0. 2 square into 4, 0, 0. 2 power 1 into 1, 2 power 1 into 1 plus 0 into 0. 2 power 1 into 1, 2 plus 0. What is the value? 2. Surely got this one? Yes, I got this one. So here we discussed decimal. Arithmetic unit means we are computer understanding language is a binary, but user understanding is a decimal. So user to computer means we are giving the input to the ALU is a decimal, but ALU is converting our decimal to binary. After the output of ALU or CPU, the binary is converting to the decimal, and this decimal is giving to the user. So here ALU means arithmetic logic unit. We are performing arithmetic and logic operations through the decimal values. Through the binary means we are converting from for the arithmetic logic unit, we are converting from binary to decimal or decimal to binary. But here for the addition and subtraction we need for arithmetic logic unit. But for subtraction we have the subtractor, subtrahend like this. But for this purposes I have to take 1s and 2s complement or 9s and 10s complement for subtraction. Here majorly in the decimal arithmetic unit we are performing addition and subtraction. For the addition and subtraction, for subtraction we are using 1s, 2s, 9s and 10s complement for subtraction. So here also we are using BCD adder and BCD subtraction, decimal to BCD, BCD to decimal. BCD is a binary coded decimal. So for addition of BCD, BCD adder we need. For subtraction of BCD we need BCD subtractor. So it is a BCD code, means BCD means 0 to 9. That is a 8421 value. Here it is a decimal from 0 to 9 and 8421 position. What is the position of this one? Here one example for decimal to binary. One example here 10 represent 10 to binary. 10 means 1 and 0. Why? Because the 10 is not in the BCD. Only 0 to 9 is there, not a 10. So what we have to do? 10 means 1 and 0 and separating. 1 means 3001. 0 means all zeros. So what is the value? 0 0 0 1 0 0 0 0 converted to BCD. So binary, it is binary means we are dividing like this. So BCD addition, 3 conditions. Sum is less than or equal to 9, carry 0, then it is correct. Sum is less than or equal to 9, carry equal to 1 means we have to add 6, then we will get the answer. Sum is greater than 9 and carry equal to 0, it is wrong. If we are going to the correct operation, we have to add a resultant 6, then we will get the correct answer. So okay, these are some examples of addition of BCD. Okay, it is about the adding 6 to that one. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.